When we talked about synthetic division, we ran across a case where we ended up with a remainder of 0. And we're like, oh yeah, that's cool because we don't have to write one of those big fractions as part of our answer. But there is another special thing about when the remainder is 0. Now, all of this stuff, that's just kind of some fancy math speak. But let me just kind of boil it down for you. If the remainder is 0 when dividing, so if we get that r value equal to 0, then that means that the divisor, this thing that we just divided by, for example in x plus 1, is actually a factor of the polynomial, and we can use that to help us with our factoring. So let me show you how this works. The first thing we're going to do is our normal dividing. All right, so we are going to do synthetic division. Remember, if we have an x plus 1 here, that's going to show up as an x or as a minus 1 for our k value or our house number. And then I need to look at this polynomial and see if I'm missing any terms. I see a 3, a 1, a 0. So yes, I am missing a term. I am missing an x squared. So I'm going to need to insert a 0 in the x squared spot. Knowing that, whenever I write my coefficients, the coefficient in front of x to the third is a 1. The next number that I'm going to write is that 0 that I'm inserting. And then I have a negative 13 and a negative 12. Now I'd like for you to pause the video here and go ahead and practice your synthetic division. You could probably use a little more practice on that. Come back here and let's go over the next steps after. All right, let's go ahead and go over this. Remember that the first step after we set up is to bring down the first coefficient, in this case a 1. 1 multiplied by negative 1, remember it's bring down, multiply, add, multiply, add, multiply, add. So multiplying is 1 times negative 1. You write it up and to the right, the negative 1. 0 and negative 1 makes negative 1. Negative 1 times negative 1 will be positive, up and to the right. This will add to be negative 12. Negative 12 times negative 1, positive 12, adds with the negative 12 to be 0. So we should have known already that we were going to get a 0 because it says show that the binomial is a factor of the polynomial. They wouldn't ask us to show it was if it wasn't. Okay, so here's how we're going to use this to factor. We are going to use this as the start of our factoring. We were told up above here that it is a factor. So this comes from the very beginning. I'm going to go ahead and write up here so that I have more room. So I'm going to say x plus 1 as part of my factored polynomial. Now what I'm going to do is go ahead and write this polynomial that's left, and what I'm going to end up with is a kind of a partially factored polynomial. So I'm going to say x squared minus x minus 12. So this step right here I was able to achieve by dividing. From here, this is a linear factor. I can't do anything with it. This is quadratic, so I know I'm going to use an x box. So that's the next thing I'm going to do is x box. Let's go ahead and fill that in. Negative 12 and negative 1. And then I need to find factors of negative 12 that add to be a negative 1. So that means that my biggest one must be a negative. So I'll start with 1 and negative 12. 2, negative 6. 3, negative 4. And the ones that are going to add to be negative 1, well, that's going to be the 3 and the negative 4. 3, negative 4. Now I want to fill in my box part to get the box part of x box. Remember that we're going to fill those in with an x squared and a minus 12 and then our 3 and 4 with x's on them. X squared minus 12 and then the values we just figured out. I need a 3x and a negative 4x. Okay, let's look at greatest common factors now. across the top row, I see an X. Across the bottom row, a -4. Across, or down, I guess I should say, the first column, X again. And down the second column, I have a 3 and a -12. Well, that's going to have a 3 in common. So I can write my next line as X plus 1, and then multiplied times X minus 4 and X plus 3. All three of these are linear terms now, so I know that I am done.